In this video, I want to do the M step for our mixture of Poisson's model. So what do we have so far? So far, we have our model, right? And we have the soft assignments that we came up with. So what do the soft assignments mean? So this number means, okay, so this is the probability that Ki came from the first Poisson distribution. This is the probability that it came from the second Poisson distribution. All right, and now we're saying, okay, assume that those are fixed, and we want to figure out the lambda and the pi that work the best for the data set. Okay, so how would we do that? So the idea essentially is to say, all right, so if this guy is large, then we're pretty sure that Ki came from the first Poisson distribution, so we'll use this Ki mostly to estimate lambda 1, right? On the other hand, if this guy is large, then that means that Ki came from the second Poisson distribution, probably, so we'll use this Ki mostly to estimate lambda 2, right? If all of those guys, if this was like either 0 or 1, this was either 0 or 1, in order to get lambda 1, what we could do is we could just like average all the k's for which this is 1. But they're not exactly 1s, they're kind of somewhere between 0 and 1. So how are we going to do it? Well, because we know that if this were 0s and 1s, we could just average the k's that belong to the first Poisson distribution in order to get its lambda. What we'll say is, well, we'll do the same thing, but we'll just kind of use those weights. So instead of saying, you cannot say this, but what you can say is lambda 1 is going to be the sum over ki's, except the ki's are going to be weighted by this wi1. Right? So instead of straight up adding the ki's, you're going to say, no, I want to take, you could say the expected count, right? So I want to take the expected sum of all the k's that belong to the first Poisson distribution. And this is going to be like this. Now, you want to divide by the number of points that come from this Poisson distribution. You don't know exactly how many because you don't know the zi's, right? But you can approximate this by saying, okay, if this is 0.9, we'll count it as 0.9 a data point. So we're going to just add up all the wi1s. And we're going to do the same with lambda 2. So that's going to be the sum over wi2 ki divided by the sum over all the wi2s. All right. How do you do the pi's? Well, you would say, so we already argued that this is really the kind of estimated number of points that came from the first Poisson distribution. So what would you do? You would say, okay, so pi1, that's going to be the estimated number of points that came from the first distribution, right? So it's going to be the sum of wi1 divided by the total number of points. One thing you could do quickly, you could of course just divide by n, that's definitely the total number of points, or kind of the way we wrote it in the solutions is we wrote it as the sum over wi1 plus the sum over wi2, because because wi1 plus wi2, that's always a 1. This is just going to be n, the total number of points, but you can do it like that. And then we can say pi2 is either the same form, or you can say pi2 is estimated to be basically 1 minus pi1 hat, because they have to add up to 1. So either way, this this form or this form would be fine. So okay, I want to elaborate a little bit on this guy. So what do I mean by this guy? So one thing I could do is I could say, okay, so what's the kind of expected value of the sum of the indicator of Zi is equal to 1 given Ki and lambda and pi, right? So I can do it kind of like that. So if this, again, if this was either 0 or 1, meaning if we knew exactly is Zi equal to 1 or 0, well, we would just count up the number of points such that Zi is equal to 1, and we'd be done. But we don't. But what we can do is, well, we can say, okay, so this is the number of points where Zi is equal to 1. So what we'll do is we'll just add up those indicator variables. So this indicator variable is either 0 or 1, we just don't know what it is. And then we'll take the expectation. So if you take an expectation of an indicator variable like this, what you'll get is you'll just get the sum of the probabilities that Zi is equal to 1 given Ki and lambda and pi, which is exactly what we did over here, because this guy and this guy, they're the same. So that is the M step, and what you would do is you would alternate between the E step and the M step until you converge in order to get the estimates for your pi's and for your lambdas, and in order to possibly label each of the k's as either belonging to the first Poisson distribution or the second Poisson distribution.